Hi guys, so in this video we'll cover chapter 16 and it's about network troubleshooting. Okay, so we're going to learn some troubleshooting skills in this class. Okay, so basically as Linux admin, once you configure the network on your system, it will be, probably you may face some encountered problems which require debugging. Okay, so in this chapter we'll actually talk about how to do the debugging and how to troubleshoot networking issues. First, I want to talk a little bit about what are the common networking issues. For example, a network interface card is not detected by the system. Okay, for some reason probably the driver is not loaded. Okay, another problem could happen on the network is IP address configuration or assignment. IP address could be assigned not correctly to the system, probably the same subnet as default gateway, probably subnet mask is wrong, and a couple of things. Okay, the third common problem is not being able to communicate with the router, and that's actually most likely, it's IP configuration. Okay, so probably the default gateway IP address is not on the same subnet as your local host. And the last problem is the DNS service not reachable. So the DNS is not working for some reason, or probably on Linux systems the resolve config file is missing the name server and other problems. Okay, so let's start with the network services. So basically I'm going to use Debian as well as CentOS, both because there is slightly different configuration on this Debian distributions and Red Hat distributions. Okay, which CentOS is one of them. So basically we'll start by actually sometimes you may need to restart the network or networking manager on your system by issuing sudo etc and then init. Okay, init-d and then networking, I'm using Debian here, networking restart. Okay, we could do that for restarting the network, or upon changes you may need to issue, you may need to issue this command. So basically you could do restart with this command, sudo etc init-d network restart. Although this command is deprecated because most distributions nowadays they use systemd instead of the init. Okay, so you could also use sudo and then systemctl here, ctl, and then restart networking .service. You could also issue this command if your distribution is supporting actually or running systemd. Sorry. If we want to stop a service, we could actually use stop service like this. Stop. You could start it again by issuing a start right there. That's the Debian distributions. Let's actually, you could do that also using the systemd command. So restart, we could check the status in here. As you can see, okay, it's failed to load. Okay, we could also issue start. Let's start it. Okay, and let's use the status again, and it still failed for some reason. Okay, I'm gonna check it out. So we have some troubleshooting guys to do in here. So basically I'm gonna issue sudo fconfig. Notice that the Debian distribution, the latest Debian distributions, I think Debian Stretch, Debian 9, Debian 10, they don't actually recognize the fconfig, but some distribution actually they you can issue fconfig and so on. So if the fconfig didn't work, you could actually issue sudo apt install net -tools, okay, like this. So I already installed them, that's why the fconfig is working. So fconfig, I'm getting an IP address on this interface, and everything seemed to be okay, so I don't have any problem here. Also the RX and TX that we're gonna mention later on, they're okay. Transmitted bits, received bits, okay. Packets, how many packets are received, how many packets are transmitted. We don't have any drops, we don't have any overruns, we don't have any collisions, as you can see the last line here. So everything seems to be okay. Failed to start raise network interface. This is just related to raising the network interface. It's complaining about the command, but normally the service is raised and looted. Okay, cool. We could also, instead of config, we could use IP address A for shortcut, IP address show, okay, or IP address sh to show the interfaces along with their IP address configuration, as you can see. So let's go to, that's for the Debian, how to start and stop the networking service. Let's go to CentOS, and we are gonna actually, the command is basically the same, except for the, instead of network, we use networking in Debian, but we use network in Red Hat distributions, okay? We could use sudo, it's a init-d network, actually, okay? Restart. We could, it's asking me for a password here. I need to be root. Restarting network via systemd. So as you can see, we are running systemd. We could also use stop. Okay, to stop. Okay, and then we could start again the network service. Okay, and we could also use systemd. As I mentioned, most distributions, they are using systemd instead. Okay, systemctl. Okay, let's check the status of the networking.service. Service here. Okay, could not be found. I probably networking. Okay, .service. Right there is not found. It's okay. Let me check here. As you can see, network online target, network.service, not networking. Networking is Debian actually, but notice the difference is just the ing. Okay, and as you can see, everything is fine. Network is loaded, and we could stop it, start it, and do whatever we like with this network. Restart. We could stop, and we could actually start, and so on. Sometimes you may need to bring the interface up and down, okay, in order for it to work. So we talked about the network services, start and stop. Now there is one command that is useful and very handy. It's called netstat. So I'm going to use netstat in here. Netstat, okay. And netstat is used with options, but we could use it just without any options, as you can see here. I'm going to scroll back to top, because there is a lot of things going on here. So as you can see, on this actually column we have TCP. We're using TCP, and as you can see here, we have the local address and the port number. Normally when packets are generated from local computer or local host, they use random port number, okay, random port number. And the foreign address, this is the source and this is the destination. The foreign address is going to mirrors dot blah 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 blah, and it's using HTTP as a port, which is port 80 in there. Sometimes you may see port number, sometimes you may see the protocol itself, and the stat is time to wait. or time wait. So may some application would be actually says established, because some application they are established. I'm gonna execute Control C to kill the this process. I'm gonna so what I'm gonna do here, I'm gonna actually start pinging. I can visit a website, for example, here, right? I'm gonna fire up Firefox, and then I'm gonna visit a website. I'm gonna show you that the established status. So let's use CentOS. Actually, yeah, it establishes a couple of things, so we could actually, yeah, and let's use netstat again, and let's give it some time. So basically it should give us some established sessions in here, okay? So I'm gonna scroll to top. There's lots of things going on. So right here, established, as you can see, okay? So it's established connection or session from localhost using random port number, and then it's using HTTPS, okay, to reach this destination right here, okay? Yeah, that's how I want to show you the established. So when you don't do anything for a while, the session will go to time wait, and then will actually disappear after a while, okay? Here we go. So if we want to view the listening ports, okay, only, you could actually issue the netstat, okay, with -L options, okay. -L option actually just the listening ports. As you can see, it's listening. The stats listening, as you can see, with -L, and yeah. So we could also issue to display, for example, the summary of details for each protocol. You could issue netstat -S like this. So as you can see, we have detailed for each protocol: TCP, EXT, UDP, packets received, okay, 0 packets to unknown port received, packets received, errors, okay, how many packets with errors, how many packets are sent by UDP using UDP, TCP, 504 active connections, and how many packets, how many segments basically are received, because the packet in the networking layer it's called a packet, but in the transport layer that uses TCP is called a segment. And then in the data link of the OSI model, if you remember, it's called a frame. I think you guessed it. So yeah, we could also use netstat -I, -I. So as you can see here, so the -I, if you want to view the details of the specific interface. So as you can see, ENS33, the name of the interface, the MTU, maximum transmission unit. This is actually 1500 bytes of data. This is the maximum transmission unit. If the packet is bigger than this number here, the device need to fragment the packet, divide it into small chunks, small pieces, and send it, and they use sequence numbers to resolve it, okay, at the destination, okay. Yeah, so you could check the details specific to each interface, okay. TX stands for transmission, RX stands for received packets, and then TX stands for, okay, transmitted packets. I just want to mention, sometimes if you are using a computer and you don't do nothing in it, you are not doing anything, and you notice that there is some open port establishing some session all the time without doing anything, it could be a virus, okay? It could be Trojan horse installed on your computer. It just, not all the time, but, most likely if there is some session that is always, all the time established, it could be a sign of a virus. Of course, with other symptoms, right? So after we saw the netstat, let's talk a little bit about configuring networking interfaces. I think we did that on the last chapter 15, network configuration. But for now, for example, if there is some problem related to networking card is not readable by your system, then the driver could be not loaded. So to load the driver, you could actually issue the sudo ls mod here, ls mod, to list all modules or drivers on your system. And then probably I'm going to go to top and search for some network card here. Okay, so TCP LP, I'm looking for a networking card in here. So NFnet link, let's check for some module in here. Yeah, exactly. So as you can see, it's this one here. It's for the Ethernet adapter. So you could actually, if this one here doesn't exist, we could actually check the information regarding this module. As you can see, this driver. So by issuing the sudo mod info right there. So the mod info followed by the module name. Okay, so as you can see, if I scroll back to top here, you could also use tail. Okay, sudo you could use head. Okay, as you can see, it's the first line. So this is actually the module that I'm using for the Ethernet 1000 or E1000 module. So I can actually let's actually delete this module here. Okay, so I'm going to use a command called so sudo rm mod, okay, and then followed by the module that I want to actually remove. I think I need to include the path. So let's do ls mod, and then look for the module. It will actually disappear because I removed this driver. Okay, so there is no E1000 here, right? Could also pipe it to less. You could pipe it to less, and then let's use mod or ls mod. Okay, ls mod, and then let's pipe it to less or more. So here we can actually search for E1000 here. Let's use E1000 and see if it does exist. So pattern not found, press return, and I'm gonna actually quit. So there is nothing there, and then I can also issue now the mod probe. Mod probe actually will load the driver back, Ethernet 1000. Okay, I can also use the sudo ns mod to insert the module, but inserting the module, you need to know the path where the module is located. Okay, so now I can issue the other command, pipe it to less / to search, and then Ethernet. I think you can see it right there. Okay, let's look for it, and it's right here. So we insert it back. Okay, sometimes the driver could be a problem, and that's those are one of the handy tools actually to install, remove, and set back the driver and so on. For the ls mod, actually we did the sudo mod, okay, mod info here, and then Ethernet 1000. Okay, we could pipe it to the head. Okay, so as you can see, this module right here, so I'm going to copy it, and the drivers in actually Linux, they end up with .co. I'm going to copy, and then I'm going to use sudo, okay, nsmod followed by this specific module. It's already there, so I need to remove it with mod and install it again, okay, for the module to be installed. But I can kill this session right here, so the module is installed. Let's use less, and the module is still there. Okay, I'm gonna quit right now by issuing Q on the keyboard. So can also ls mod and grep, okay, and use grep like Ethernet 1000. Okay, as you can see, the module is loaded and everything is fine. If you don't see something like this, then the module is not loaded, so you need to load the module. After loading the module, let's do grep ens33. Nothing there. Next step, when you load the driver, okay, in Linux, you could check with the ifconfig, okay, ens33 in here, and then as you can see the information regarding this specific interface. And I'm gonna talk a little bit about a couple of important things. So for the RX, okay, there are RX errors, okay, received errors, as you can see, it's 0. Dropped errors, those are the packets that are dropped. Those are packets that are actually have errors in them. Those are overruns. So there is giants and overruns. Overruns are packets that are less than the maximum transmission unit, the MTU, which is 1500. The giants, I cannot see them here, but the giants are actually more than the maximum transmission unit. Okay, the TX, okay, transmitted packets, as you can see, how much. And here at the last line, okay, as I mentioned earlier, we have transmitted packets with errors, how much, as you can see, 0. Packets that are dropped during transmission, the overruns, the small packets that are lower than the maximum transmission unit, and collisions. Collision basically in Ethernet world. So packets collide if you have, for example, connected to a switch and your host is using full duplex. The switch is actually using half duplex with 10 meg per second speed, and you're transmitting with 100 meg per second speed. You could face some collisions in here. Okay, so packets collide. So those are one of the tools that you can check the interface for errors and so on. Okay, so starting and stopping network interfaces with the fdown and fup command. So we could issue the sudo if, okay, ifconfig or fdown command. Let's use fdown command followed by ens33, so you could make the interface down successfully. Down ifconfig -a, as you can see, -a shows me all the interfaces including this one here, and as you can see, it's down. If I use fconfig again right there, it wouldn't show me the it's showing me the interface, but as you can see, there is no IP address and nothing, which means the interface is in down state. Okay, We could also bring the interface up with F up, or we could bring it down and up simultaneously at the same time with one command. We could do that also. So we could sudo if down, okay, ENS33 semicolon, and then if up, okay, and ENS33 right there. So bring it down, bring it up at the same time. And access denied, failed to load connection, access denied. Why is that? And probably okay, it's complaining about this. Okay, here we go. So it needs the super user, and after that we could actually so after bringing the interface down, interface up, checking the IP address, as we mentioned, we could use fconfig to check the interfaces, IP add show as well to check the IP address assigned to each interface, and so on. As you can see, the interface will bring it up and it gets an IP address, okay, the broadcast, and a couple of information regarding the specific interface. So first, use the fconfig command to assign. We could assign an IP address to an interface, okay. For example, I could change this one here to another IP. So I'm going to use sudo, and then I'm going to assign the IP address to a specific interface. So sudo fconfig, okay, followed by the interface name ENS33, and then I'm going to use 192.168, okay, let's say 172.16.1. Let's say 9, followed by the netmask, and then the netmask, let's use /24 in here, and here we go. So let's do fconfig now and see what's happened. So immediately take effect. If not, we could restart networking with the command that I already showed you before. Okay, if down, if up, or we could restart the entire service, networking service, and so on. So as you can see, this IP address is not permanently assigned. Okay, if we want permanently to be assigned, we can use a static IP address that I'm gonna show you right now. So after assigning interface an IP address, either statically or via DHCP, you can view the interface via using fconfig. Okay, and if the interface didn't get an IP address for some reason, check that the your DHCP is configured correctly. Okay, DHCP server, the remote server, is configured correctly. Okay, sometimes you may see like an IP address like this. It's IPPA. It's private automatic IP addressing. So when the host actually boot up and ask for an IP address from DHCP, it didn't find any DHCP server, so it goes ahead and assigns itself 169.254.x.x. So every IP that starts with this, okay, it's an IPPA address. So if you notice some interface that is have an IPPA address, you could check, okay, you could shut it down and bring it up and restart. It may get an IP address. If not, check that DHCP is there, or rather is providing or allocating IP addresses via DHCP. Regarding static IP address, that's the last thing that I'm going to talk a little bit about. Okay, so sudo nano etc networking or network. I'm in CentOS. Okay, this is not Debian. Sysconfig, and then sys. No, I think it's sys. It's a sys. Okay, sysconfig. Okay, and then let's actually use sys. I think network scripts here, and then the CFG, and then the interface name right there. So we could actually go to specific interface, or we could go to the scripts itself. There is nothing there, so I'm going to exit. I'm going to go and CFG ENS 33. It's not 3, it's ENF. That's 33 here. Okay, so as you can see here, we could configure a static IP address, as you can see. So boot protocol is set to DHCP. We could set it to static. Okay, default route we could use yes. We could keep it yes right there. IPv4, IPv6. Okay, autoconfig. Okay. And down here we could actually on boot yes, so this starts on the boot when computer boots, and here we could add the IP address, the gateway, and we could add the network and other information if we want to set it to static. So we need to mention static in here, and then right down here, okay, right below, we could actually add the address equals and the IP address between parentheses. Normally we could do that IP address, something like this, and then between double quotes we could give it an IP address 172.16. Let's say 1.8 for example. Okay, we could use mask or net mask. Okay, mask, I think a net mask, and then net mask equals this, and so on. I think you get the idea. I'm gonna comment those lines, or I can actually exit without saving. No, here we go. Regarding the configuration of Debian, we mentioned it a couple of times. It's similar, except for the Debian actually sudo nano. It's a network here, then interfaces. That's the place where all the networking configuration is there. So in here we could, if we want to add a static IP address, we could do that. I didn't actually check what are the interfaces I have, so I need to be a super user. fconfig here. So ENS33 exactly. So sudo nano, it's in network interfaces, and I can go here and then auto ENS33. I mean 33 here, and then I face ENS33 inet, and then inet static. Okay, address. There is no equal here regarding Debian, and then we could actually give it an IP address 72.16.1. Let's say 7. Net mask 255.55.55/24. Gateway, okay, is let's say 172.16.1.1, and that's it. We could add DNS and other information, but that's enough. Okay. Okay, it's asking me, so that's how to configure it. So we could, okay, and then fconfig and check the IP address. I need to be super user. Okay, and see that the IP address is changed. If it didn't change, you could restart the service, networking service, and then everything will be okay. I just want to mention one more thing, okay, regarding the DNS. So if you can, for example, ping a server with an IP address, but you cannot ping with, okay, with the name, can ping this. but you know that the server has a name, they cannot ping the name, which means you have a problem in DNS. You could use ns lookup. Let's look up and check the host name or the domain name. ns lookup, it seems that ns lookup is not there. Or we could use ns lookup, okay, and then google.com, for example. It's not actually installed it, so sudo apt install net tools, install ns lookup here. Let's check with the dig command, sudo dig, dig and then google.com. Okay, so the dig is not there. So the dig google.com. Let's use sudo route. Exactly, so we have route, IP route. So let's check where is ns lookup. Let's look for this one. I think it didn't exist. Sudo apt install ns lookup. ns lookup is not read in state. Enable to locate ns lookup. I think it should be included. I'm going to use sudo okay, so we could use ns lookup, but it's not included here. Let me check the CentOS. Let's use ns lookup here. As you can see, it's right there. ns lookup, and we could use google.com to check the ns lookup. So this is the name mapped to an IP address. Okay, we could use also dig command, dig google.com. And dig gives me information regarding the query and the answer from the authoritative server that is hosting google.com. Okay, and that's it. So I just wanna, the last, actually sometimes the resolve.config file could be missing the name server to resolve. Okay, name server, as you can see, I'm using correct name servers, as you can see right there, but sometimes if you don't use them, you will get problems regarding that, so you may check the resolve.config file. I hope this has been informative for you, and I would like to thank you for the CastLN for my Linux students. Please, I want to, after watching the video, I want you to finish the lab and the chapter exam 16, okay, tomorrow. And I hope this has been informative for you, and I would like to thank you.